Dear students, I am Dr. M. Anwar Sadiq, Associate Professor of Chemistry, Jamal Muhammad College. In this presentation, I would like to explain some basic concepts of electrochemistry. What is electrochemistry? Generally, it is the study of electricity and how it relates to chemical reactions. In another way, electrochemistry may be defined as the conversion of electrical energy into a chemical energy and vice versa. According to first law of thermodynamics, one form of energy may be converted into another form. Therefore, this definition is more optimum. In electrochemistry, electricity can be generated by movements of electrons from one element to another in a reaction known as redox reactions or electrochemical reactions. Why electrochemistry is important? For the manufacture of battery or working principle of fuel cells, electrolysis, similarly electroplating, these are all very much day-to-day applications of electrochemistry. Corrosion is a natural, spontaneous decaying process. Here, loss of material may take place. Here also, electrochemical principles are directly involved. What do you mean by Ohm's law? Ohm's law states that the voltage or potential difference between 2 points is directly proportional to the current or electricity passing through the resistance and directly proportional to the resistance of the circuit. Simply, V is equal to I into R, where V is equal to voltage, I is equal to current, and R is equal to resistance. From this law, we have to calculate the power, efficiency, current, voltage, and the resistance of an element of an electrical circuit. From this law, we have to modify or we have to calculate current or resistance or voltage from simple mathematical modification. For example, if the resistance of an electric ion is 50 ohm and a current of 3.2 ampere flows through the resistance, find the voltage between 2 points. We know that the mathematical formula of Ohm's law, V is equal to I into R. In this problem, what is the need is calculation of V, that is voltage. R and I both are given. R is equal to 50 ohm, I is equal to 3.2 ampere. The unit of resistance is ohm, the unit of current is ampere, the unit of voltage is equal to voltage. Here we have to directly apply this formula. V is equal to 50 ohm into 3.2 ampere. Finally, we get 160 volt. And then, what do you mean by conductance? The ability of a material to conduct electricity is simply known as conductance, or measure of how fluently electrical current passes through a material, or the inverse of electrical resistance is also known as conductance. Conductance is generally represented by capital G or capital C. The formula of conductance is G is equal to 1 by R. That is, the relationship between conductance and the resistance is inversely proportional relation. The unit of conductance is Simon. This is the SI unit. The other units are ohm inverse or mho. Generally, metals are examples for good conductor. Why? Because Metals are generally electron deficient in nature. These are all generally called as Lewis acids. Therefore, metals are very good conductors. Similarly, electrolytic solutions are also example for conductor. Now, we have to learn some relations or differences between metallic and electrolytic conductors. Already I pointed out metallic conductance or electrolytic conductance is generally defined as the ability of a material to conduct electricity. And specifically, the ability of a metal to conduct electricity is known as metallic conductance, whereas the ability of an electrolyte to conduct electricity is known as electrolytic conductance. Here, what do you mean by electrolyte? Any chemical substances is dissolved in water and dissociate cation and anion. This kind of substances is known as electrolyte. In simple form, a material have an ability to dissociate ions in a solution. What is the primary cause of conductance for metallic conductor? Here, flow of electrons may take place. Flow of electrons from generally negative potential to positive potential, or higher negative potential to lower negative potential. In the case of electrolytic conductance, migration of charged ions takes place. That is, flow of charged ions towards the oppositely charged electrodes. Right? Examples for metallic conductance are aluminum, silver, iron, copper, gold. These are all very good examples for metallic conductors. Whereas in the case of electrolytic conductors, solution of acids, solution of bases, salt in water are examples. Metallic conductor is also known as electronic conductor, whereas electrolytic conductor is also known as ionic conductor. In the case of metallic conductor, there is no chemical reaction. Similarly, there is no product formation. Whereas in the case of electrolytic conductance, electrochemical reaction may take place. That is a redox reaction, reduction and oxidation. Gain of electron is reduction, loss of electron is oxidation. The major product is electrodeposition may take place. What is the effect of temperature on metallic conductor? Generally, if the temperature increases, metallic conductance gradually decreases. Why? Because this is due to increase of specific resistance. The relationship in between resistance and the conductance are inversely proportional. Here, specific resistance increases, automatically metallic conductance decreases. Whereas in the case of electrolytic conductance, if the temperature increases, automatically electrolytic conductance increases. This is due to increase of mobility of ions and also increase in the degree of dissociation. That is, the formation of number of ions or increases or enhance, especially in the case of weak electrolytes. Now, move to what is the difference in between specific and the equivalent conductance. Specific conductance may be defined as the conductance of per unit volume of the cell, whereas equivalent conductance may be defined as the conductance of all the ions produced by 1 gram equivalent of an electrolyte in a given solution. Specific conductance is denoted by small k, that is kappa. Equivalent conductance is represented by lambda. the mathematical formula of specific conductance equal to L by A into G. L by A is nothing but cell constant. G is observed or measured conductance. Here, equivalent conductance lambda is equal to 1000 into kappa, that is specific conductance, divided by concentration of an electrolyte. The unit of specific conductance is ohm inverse and centimeter inverse. Ohm inverse and centimeter inverse. Whereas in the case of equivalent conductance, the unit is ohm inverse, centimeter square, equivalent inverse. What is the effect of dilution on specific conductance? Generally, if the concentration of the solution decreases, in other words, dilution increases, specific conductance decreases. Why? This is due to the number of ions per unit volume of the solution becomes less. Whereas in the case of equivalent conductance, generally increases. This is because the degree of dissociation and the total number of ions increases. Based on the above formula, now we have to calculate one problem. Specific conductance of a decimolar solution of potassium chloride at 18 degrees centigrade is 1.12 Simon per meter. The resistance of a conductivity cell containing the solution at 18 degrees centigrade was found to be 55 ohm. What is the cell constant? Here our need is calculation of cell constant. Resistance and specific conductance values are given in the problem. What is the resistance? R is equal to 55 ohm. What is the specific conductance? K is equal to kappa is equal to 1.12 Simon per meter. We know that cell constant is equal to specific conductance divided by observed conductance. Here observed conductance value is directly not given, not provided in this problem. But we have the value of R, that is resistance. What is the relationship between resistance and conductance? Conductance is equal to 1 by R. Therefore, we get conductance value from R value. G is equal to 1 by 55 Simon or ohm inverse. Now substitute these values directly in the formula. Finally, we got cell constant 61.6 per meter. Another one problem based on the above theory. The resistance of 0.01 normal NaCl solution at 298 Kelvin is 200 ohm. Cell constant of the conductivity cell is unity. Calculate the equivalent conductance. Here, the need of the problem is calculation of equivalent conductance. Some parameters are given. R is equal to 200 ohm, that is the resistance. K is equal to 1 centimeter inverse. The normality of the solution is 0.01 normal. Here we know that lambda is equal to K into 1000 divided by normality or molar. In the first step, we have to calculate specific conductance. Specific conductance is equal to 1 by R into cell constant. 1 by R is equal to 1 divided by 200 ohm into the cell constant is equal to 1 centimeter inverse. Because here the cell constant of the conductivity cell is unity. Unity is nothing but 1. From this, we get this specific conductance value 5 into 10 power minus 3 ohm inverse centimeter inverse. From this, we get equivalent conductance. We know that kappa is equal to 5 into 10 power minus 3 ohm inverse centimeter inverse. This value is directly applied in the formula. Finally, we get equivalent conductance of a particular solution. 5 into 10 power 2 ohm inverse centimeter square and per equivalent. Dear students, in this presentation, I tried to explain the following items. What do you mean by electrochemistry? Electrochemistry is simply defined as the interconversion of electrical energy into chemical energy and vice versa. Or we have to supply electricity in a chemical system. What happens? And then what are the major applications or importance of electrochemistry? In our day-to-day life, electrochemistry or electrochemistry principle laws are directly or indirectly applied. For example, battery energy storage devices, fuel cells, electroplating. Electroplating is a vast area. From this, we have to get a pure metal. In the metallurgical sector, we have to purify a metal from unwanted matters. Similarly, electroplating is another area to prevent corrosion, metallic corrosion. Corrosion is nothing but destruction or disintegration of a metal. Electroplating technique is used to prevent the corrosion. Here also we get Ohm's law, and also we get the meaning of conductance. Similarly, types of conductance, metallic and electrolytic conductance. What is the meaning of specific conductance? Differences in between specific and equivalent conductance. Thank you very much for your kind listening. Thank you very much.